afternoon, everybody. Taking a look today at a little bit more work with scientific notation. So as I stated last week, most of our work with scientific notation is going to be, can you move it from standard to scientific? Can you move it from scientific to standard? And can you make some comparisons? So this first part is a little bit of the review of comparisons. Okay, so we're comparing very large or very small quantities. The mass of a proton being 1.7 times 10 to the negative 24th, and I'll move this up, grams. The mass of electron being 9.1 times 10 to the negative 28 grams. Okay, so this is our proton, and this is our electron. Okay. Now, as we know from negative numbers, a negative 24 has greater value, is better than a negative 28. Okay, so proton is larger. Okay, I'll move this up there. There you go, guys. Okay, so my proton is larger. I can tell just by the exponents. How much larger? Okay, just like we learned last week, we're going to compare the larger leading number, okay, and make a comparison there. So we're going to take 1.7, the number of the proton, divided by 1.9, okay, the number of the electron. Oh, I'm sorry, 9.1. Okay, and we're just going to divide that. This would be a good spot for a calculator. Okay. So 1.7 divided by 9.1. Okay. And that equals 0.186813. It keeps going, but that's plenty for what our needs. Then we look at the difference here. The proton is 4 greater in exponents. So this is times 10 to the 4th power. Okay? Now, 10 to the 4th power is 10,000. So if I multiply that, I get approximately 1868.13 times larger. Okay, exactly what we did last week. The only change that we are making in this example is that there are decimals here. We're doing the exact same thing. We just don't have whole numbers or integers. We are working with other good rational numbers. That's it. So that is how we prove that it is over 1,800 times larger than the size of an electron. This is the entire purpose of scientific notation. Things are so big or so small that the only good way to compare them is something like this. Okay? So there is one example. In this lesson, normally I would split this lesson in two, but for some pacing reasons, we're not. Okay? So in this lesson, we're going to do a couple more examples. And in these examples, okay, we are going to make some comparisons. Okay? Here's your big idea. Comparisons are easy if you either make them the same exponent value, okay, exponent value, or you understand how to determine which one's larger from the beginning, okay? In this case, they're saying how many fewer, not how many times, how many. So what they want here is subtraction. Because of that, comparisons we can do with the things different. Calculations need same exponent value. Okay, and here I'm going to give you an example of what I mean, because just in words that is a little confusing. Okay, so 48 states, the main body of the United States of America. 3.12 times 10 to the 6th power. Alaska, all by itself, 6.63 times 10 to the 5th power. Okay. The truth is, the entire United States is bigger, but as you can tell, not by a ton. In order to subtract these, I need to make these exponents match. So I'm going to take this out of scientific notation. It's going to break the scientific notation rules. Okay? And I'm going to write it. Now notice, this broke the scientific notation rules because I now have a leading number that's more than 10, more than 10. For the purpose of what we're doing, that is okay. The value stayed the same because I moved a tens value here and a tens value here. I balanced it. Now I could write 31.2 times 10 to the 5th power, 6.63 times 10 to the 5th power, and I could simply subtract my decimals. Because these are the same, they can just stay alone. Okay, they could just be. So now I have 31.2 minus 6.63, and I have 24.57 times still 10 to the 5th power. It didn't go away. It just was able to transfer with. We're only dealing with the leading numbers, which is 24.57 okay. Alaska is 2,450,000 fewer square miles than the entire United States all put together. Okay, it's still huge. Now let's see if that makes sense. To have it make sense, we're going to put 48 states at 3.12, 10 to the 6th. Okay, Alaska, 6.63, 10 to the 5th. Oops. Yeah, that math lines up. Okay? So the difference in the 48 states versus Alaska, okay, that lines up. You can always use standard form to check the reality of your solution. Okay, one more. Over time, the ocean floor moves apart under underwater mountains and trenches. The Mid-Atlantic Ridge, which you would have studied with plate tectonics, okay, the East Pacific Rise, again with plate tectonics. How many meters has the Mid-Atlantic Ridge moved in 6 million years? So it's this much per year times 1 million. Okay? So that's what I want to look at. I'm sorry, 60 million, not 1 million. Okay? So the Mid-Atlantic Ridge, 3.15 times 10 to the negative 2 power, okay, times 60 million. Okay, do we see that? 60 million. 3.15 times 10 to the negative 2 power times, and I'm going to put this as its own entity, 6 times 10 to the 1, 2, 3, 1, 4, 5, 6, 7th power. Now, in order to deal with these, okay, we would have to deal with the exponent piece of them. Okay, and we're going to finish that up in class. So just so you know, the big idea is we have to have the same exponent in order to do the calculation. Okay, in this case, if I wanted to make it to the negative 2, we would have to shift some things up, and we will finish that up in class. I appreciate you guys, and I will